So in we have a introduction large language model. So in every chatbot we use the model. Large language models are becoming increasingly capable of handling complex multi-step tasks. So advances in the reasoning, multimodality, and tool use have unlocked a new category of LLM-powered system known as agents. So agents are the specific for the task independently without human intervention or less human intervention. This guide is designed for the product and engineering teams exploring how to build their first agent. This telling insights from the numerous customer deployments into practical and actionable best practices. It includes framework for the identifying promising use cases, clear pattern for the designing agent logic and orchestrations, and best practices to ensure an agent runs safely, predictably, and effectively. After reading this guide, you will have the foundational knowledge you need to confidently start building your first agent. So, what is an agent? So, while conventional software enables user to streamline and automate workflows, agents are able to perform the same workflows on the user behalf with a high degree of independence. As we discussed last slide, it is totally independent. So agents are the system that independently accomplish tasks on your behalf. A workflows is a sequence of steps that must be executed to meet the user goals, whether that is resolving a customer service issue, booking a restaurant reservations, committing a code change, or generating a report. Applications that in, integrate large language models but do not use them to control workflow execution. Think simple chatbots and a single term large language model or sentiment classifiers are not agents. More concurrently, an agent processes core characteristics that allow it to act reliably and consistently on the behalf of the user. It leverages on large language model to manage workflow execution and make decisions. It recognizes when a workflow is complete and can proactively correct its actions if needed. In case of failure, it can halt execution and transfer control back to the user. It has access to the various tools to interact with external systems, both to gather context and to the take actions, and dynamically select the appropriate tools depending on the workflow's current states, always operating within the clearly defined guidelines. So, when should you build an agent? Building agent require rethinking how your system make decisions and handle complexity. Unlike conventional automation, agents are uniquely suited to workflows where traditional deterministic and rule-based approaches fall short. Consider the example of payment fraud analysis. A traditional rule engine work like a checklist and flagging transaction based on the persist criteria. It construct an large language model agent function more like a seasoned investigator evaluating context, considering subtle patterns, and identifying suspicious activities even when clear cut rules are not violated. This nuanced reasoning capability is exactly what enables agents to manage complex, ambiguous situations effectively. So, as we evaluate where agents can add value, prioritize workflows that have previously resisted automations, especially where the traditional method encounter frictions. So complex decision making is there, difficult to maintain rules and heavy resilience on unstructured data. Complex decision making workflows evolving nuanced judgment expectations or the context sensitive decisions, for example, refund approval in customer service workflows. Difficult to maintain rules. Systems that have become unwieldy due to extensive and intricate rule sets, making updates costly or error prone, for example, performing vendor security reviews. Heavy reliance on the unstructured data. Scenarios that involve interpreting natural language, extracting meanings from the documents, or interacting with the user conversationally, for example, processing a home insurance claim. Before committing to building an agent, validate that your use case can meet these criteria clearly, otherwise, a deterministic solutions may suffer. So, agent design foundations. What agent design foundations? It is the most fundamental from an agent consists of the three core components: model, tools, and instructions. So, model, I have a model. So, the large language model powering the agent reasoning and decision making. Tools, external function or API the agent can use to take action, instructions, explicit guidelines, and the guardrails defining how the agent behaves. Here is what this looks like in a code when using OpenAI Agent Software Development Kit. You can also implement the same concept using your the preferred libraries or buildings directly from the scratch. So in Python coding, whether agent is equal to agent. So new weather agent instructions, you are helpful agent who can talk to the user about the weather. Tools is equal to get weather. Selecting your models. So selecting your model, different model have different strength and the trade-offs related to the task, complexity, latency, and the cost. As we will see in the next section on orchestrations, you might want to consider using a variety of models for different tasks in the workflows. Not every task requires the smartest model. A simple retrieval or intent classifications task may be handled by a smaller, faster model, while harder tasks like deciding whether to approve a refund may benefit from a more capable model. An approach that works well is to build your agent prototype with the most capable model for the every task to establish a performance baseline. From there, try swapping in the smaller models to see if they still achieve acceptable result. This way, you do not permanently maturely limit the agent abilities, and you can diagnose where the smaller models succeed or fail. In summary, the principles for choosing a model are simple. Step up evolves to establish a performance baseline. Focus on meeting your accuracy target with the best model available. Optimize for the cost and latency by replacing larger models with the smaller ones where possible. You can find a comprehensive guide to selecting OpenAI model here. So defining tools. Next slide is based on defining tools. So tools extend your agent capabilities. So by using API, so application programming interface, with the help of that we can interact with a particular software or through API. So tools extend the agent capabilities through API. from underlying application or system. For legacy system without API, agent can rely on computer use models to interact directly with those applications. For old project, we called legacy system like old project or old system without API. Through web and application UI, just a human code. Each tool should have a standardized definition enabling flexible many-to-many relationship between tools and agents. Well documented, thoroughly tested, and reusable tools improve discoverability, simplify version management, and prevent redundant definitions. Broadly speaking, agents need three type of tools. So we have a three type of tools, type, description, and example. So we have data action and orchestration. So in data enable agents to retrieve context and information necessary for executing the workflows. Query transactions, databases or system like CRM, read PDF documents or search the web actions. Enable agents to interact with the system to take actions such as adding a new information to databases, updating records or sending messages, send emails and text, update a CRM record, hand off the customer service ticket to a human. Orchestration agents themselves can serve as the tools for the other agents. See the manager patterns in the orchestration sections. A refund agent, research agent, and writing agent. So these we have, for example, here how you could equip the agent defined above with a series of tools when using the agent software development kit Python. From agents, import agents, web search tool, functions. So at the rate functions underscore tool, we have the definition of one method and where we are giving the output, save result. So DB here we are inserting the into the database and output is the timestamp is there to time method and file saved. Search agent which is used for the searching the agent. The instruction help the user to search the internet and save result if asked. So tool is web search tool or save result. As the number of required tools increases, consider in splitting tasks across multiple agency orchestrations. So configuring instructions. Next is configuring instructions. High quality instructions are essential for any large language model powered app but especially critical for the agents. Clear instructions reduce ambiguity and improve agent decision making, resulting in smoother workflow execution and fewer errors. Best practices for agent instructions. Use existing document. When creating routines, use existing operating procedures, support a script or policy document to create large language model friendly routines. In customer service, for example, routines can roughly map to individual articles in your knowledge base. Prompt agents to break down tasks. Providing smaller, clearer steps from the dense resources help minimize ambiguity and help the model better follow instructions. Define clear actions. Make sure every steps in your routines correspond to a specific action or output. For example, a steps might instruct the agent to ask the user for their order number or to call an API to retrieve account details. Being explicit about the action leave less room for the error in interpretations. Capture edge cases. Real world interactions often create decision points such as how to proceed when a user provides incomplete information or the ask and unexpected questions. A robust routine anticipates common variations and includes instructions on how to handle them with conditional steps or branches such as an alternative steps if a required piece of info is missing. So you can use advanced model like 01 or 03 mini to automatically generate instructions for an existing document. It is a simple prompt illustration this approach. Onset, you are the expert in writing instruction for large language model agent. This is the prompt. Convert the following help center document into the clear set of instructions written in a numbered list. The document will be policy followed by a large language model. Ensure that there is no ambiguity and that is the instructions are written as the direction for an agent. The help center document to convert is then following. Orchestrations. When with the foundational component in place, you can consider orchestration pattern to enable your agent to execute workflows effectively, while it tempting to immediately build a fully autonomous agent with a complex architecture. Customer typically achieve greater success with an incremental approach. In general, orchestration patterns fall into the two categories: single agent system and multi-agent system, where a single model equipped with appropriate tools and instructions execute workflows in a loop. And in multi-agent system, where workflow execution is distributed across multiple coordinated agents. Let's explore each pattern in detail. Single agent system. So in last session, we discussed the single agent system through agent and multi-agent system. Some other agent system was also there. So in a single agent can handle many tasks by incrementally adding tools, keeping complexity manageable and simplify evolution and maintenance. Each new tool expands its capabilities without prematurely forcing you to orchestrate multiple agents. So input agent and output. So we will give the input to the agent and it will give the output based on instructions, tools, guardrails and hooks. Every orchestration approach need the concept of a run typically implemented as a loop that lets agent operate until an exit condition is reached. Common exit condition include tools called a certain structure output, errors, or reaching a maximum number of turns. For example, in the agent SDK, agent are started using the runner dot run method, which loops over the large language model until either a final output tools is invoked defined by a specific output type. A model return a response without any tools calls. So Python agent or run agent user message what is the capital of USA. This concept of a while loop is a central to the functioning of an agent in multi-agent system. As you will see next, you can have a sequence of tool calls and hands-off between the agents, but allow the model to run multiple steps until an exist conditions is met. An effective strategies for managing complexity without switching to a multi-agent framework is to use prompt templates. Rather than maintaining numerous individual prompts for distinct use cases, use a single flexible base prompt that accepts policy variables. This template approach adapts easily to various contexts, significantly simplifying maintenance and evaluations. As new use cases arise, you can update variables rather than rewriting entire workflows. So onset, you are a call center agent, you are interested with the user first name, you can be a number of user tenure. So we are creating an agent who are able call center agent interact with the first name. It will ask the first name. The user most common complaint are about categories. Greet the user, thank them to being a loyal customer and answer any questions a user may have. So when to consider creating multiple agent, our general recommendation is to the maximize a single agent capabilities first. More agent can provide intuitive separation of concepts, but can introduce additional complexity and overhead. So often a single agent with tools is sufficient. For many complex workflows, splitting up prompt and tools across multiple agents allow for the improved performance and scalability. When your agent fail to follow complicated instructions or consistently select incorrect tools, you may need to the further divide your system and introduce more distinct agents. So complex logic and tools overload is there. So when prompt contain many conditional statements like if and else branch and prompt template get difficult to scale, consider dividing each logical segment across separate agents. So to the overload, the issue is not solely the number of tools, but their similarities or overlap. Some implementations successfully manage more than 50 well-defined distinct tools, while others struggle with fewer than 10 overlapping tools. Use multiple agents if improving tools clearly by providing descriptive names, clear parameters, and detailed description does not improve performance. So this is all about tools overload. Multi-agent system is also there. So this we will discuss in a next lecture. If you like this video, you can like, share, or subscribe, and you can also comment for the best lectures we will discuss in the next topic. So you can comment and write your queries there. So I will reply to them. Some of them I will try to reply all of them. So thank you for watching. Jai Hind, Jai Bharat. Goodbye.